right, so we're going to look at a couple more identities. We've got cofunction, double angle, half angle. They're exactly what they sound like. The cofunction may not be as self-explanatory, but double angle means 2 times an angle. Half angle means taking an angle and cutting it in half. If you look at the yellow formula sheet that you have right in front of you, where is it? Good. Capital G. If you look at the formula sheet that's right in front of you, you can see that I just went ahead and put them all on there. And if you go to where it says double angle towards the bottom, notice it says sine 2x, tan 2x, cosine 2x. That means that's the implication of it's a double angle. And then if you look at the half angle part, notice it says x over 2 for all 3 of them. That's the implication. It's a half angle, okay? The cofunction one, you'll see that in a second. Open your notes. This is exactly the same approach as the end of 7.1. The end of 7.1, which was where we were having to take the sine and cosine sum and difference formulas and apply them. This is the same concept. It's just now it's a cofunction, or it's a half angle, or it's a double angle. How did your notes look? Okay. You're going to notice that your notes right here look slightly different than what mine look like. And I'm trying to fix this, but my memory is blurry from last year on what the right way was to fix this. I believe your notes are correct, and I believe mine is messed up. So just bear with me on that part. But what you have on your paper is correct. It's just I was trying not to provide you with too much information. So ignore the identities in the box. Go to number 1. It says prove the identity, and then it says sine of x plus pi over 2 equals cosine x. So a couple of things here. First of all, this says prove. That's different. Go back to 7.1. All of ours said find. Like find it, evaluate it. This is saying prove it. This is where we're going, by the way, with our next section. So go ahead and start letting me plant the seed there in your head about what this means. When they say prove, and then they give you this equation, they're telling you you need to manipulate one side in order to reflect the other side. So this is actually, in my mind, this is easier because you don't have this open-ended, hey, just find it. In my mind, I like the ones that say prove because I know what the end game is. Like, that's the answer. I have to somehow figure out how to manipulate this to get there. So you see how, take that as a chance to relax because the answer's right in front of you. You just have to figure out the work in between. Does that make sense? So when you get these prove questions, they're giving you what to start with. They're telling you where to end. You've got to figure out how to get the work in between, okay? Which is exactly why we're doing this test on paper with me instead of my math lab. All right, so we're going to take this. Why is it not working? There it is. And we're going to use the formula from 7.1. So if you want to copy wherever you have some space, and you may have more space like up above the box instead, but we're going to use the exact formula from 7.1 right here in order to prove this. So I copied the formula down for you, which is that if you have the sine of 2 values being added, then it's sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. And so now we're going to plug everything in as we see it, and then we're going to manipulate it down. So where I have u and v here in the formula, my u will be x and my v will be pi over 2. So I'm going to go through here and replace the u with x and the v with pi over 2. And then now this is where your formula sheet is helpful because I put your unit circle on there. So you cannot evaluate every single one of these. Like where it says sine x, we don't know what x is, so you cannot evaluate that. So that just stays put. But where it says cosine pi over 2 and sine pi over 2, that you can evaluate. Remember, and I have to be careful here because she's taking the test, but remember sine, you look at one certain coordinate, and cosine, you look at another certain coordinate. So you're going to go to your unit circle right now, and you're going to pull those values for just these two. Oh, that was too big. All right, you're going to pull those values for those. Those are the only ones you can actually pull from the unit circle. You're going to rewrite the whole thing. But when you get to the cosine pi over 2 and sine pi over 2, you're going to put those numbers in. Did you get that? That was just evaluating, right? And then now you're going to clean it up. The basic rules of like multiplying with a 1 and multiplying with 0 apply here. You multiply anything with 0, goes away. So this is a new point. This goes away. And then this ends up being just cosine, which is exactly what it was supposed to be. Which is exactly why I like proof questions, because then you get this feeling of, got it. Next.
So since you are just going into the formula circle,
The X or the Y. Yeah.
So you only do one of them. You don't do
So the sine x and the cosine x, since we don't know what x is, they're just in there like variables, and they just tag along. And also, if you look at the end game, you can see, okay, so at some point there should be a cosine x, and it should still be in my problem as I'm breaking it down, you know what I mean? So that's where using the right side of the equation as a nice like guide is also helpful too. Let's do another one. Come right here. It says find an identity, which is a nice way of saying, hey, take what you just did and do it again. And now what you're noticing, if you look up here, sine of some value plus pi over 2, right? That's how you read that. Is, doesn't matter what the value is, if you're adding pi over 2 to it, you come to what? Cosine x. This is a formula that's on your formula sheet. If you look at your formula sheet that you just got, it's at the bottom, towards the bottom. Look at the Cofunction Identities section on your formula sheet, and it's the very first one. We just proved that. So this slide here is an inadvertent way of deriving these formulas to show you how they came about, okay? Now we're going to repeat with tangent of some angle plus pi over 2. Okay, so we're going to, got to go back to 7-1, which is on your formula sheet. Go to the tangent sum formula. Where is it? Okay, so it's kind of in the middle to the far right. Oh no, we could go easier. Let's go easier. We could do tan u, tan x plus tan pi over 2. We can do it two ways. Let's see. I think I end up, I do. We'll save the derivative for over here. So let's come right here. We're gonna do this two ways. One, the short way right here, because we don't have a lot of space, and we'll do it the long way on the next slide. So this is saying tan of some number, some angle, plus pi over 2, right? Well, what is tan? So keep in mind, I'm out of room. Right? Okay, so I'm just going to rewrite this as the exact same mess it started as, but in terms of sine and cosine. So all I did there was take tan of some mess, and I just rewrote it in terms of sine and cosine of the same mess. I haven't evaluated anything. Now we can use substitution. Look at your formula sheet, or look at your box of formulas at the top of this slide. Look at your box of formulas at the top of the slide. Find what matches what we have here. So find sine of an angle plus pi over 2. That's the one we just did. Find sine of an angle plus pi over 2. What does that end up being? So right here where this mess is, I'm going to replace that completely with cosine x. Now find in the box on the slide cosine of some angle plus pi over 2. See, mine is, I need to make a note to myself. So the one on your paper, is that what y'all have? Minus. Wait, you have a minus on there? Does that match yours now? Yeah. Alright. Find cosine of an angle plus pi over 2. That would be right here. What can I replace it with? Negative sine x. Can I clean that up? The answer is yes. First of all, is the entire thing positive or negative? The whole thing's negative, so my answer will be negative, okay? And do they have the same of part? Right here. This has to match. They do. They match. So instead of cosine over sine, can I write this? Yep. Yeah. Do y'all see how I got that? Okay, let's look at secant of x minus 90. We're going to manipulate it the same way we manipulated this. We don't have a secant formula up here, so we're going to rewrite secant in terms of what its reciprocal function would be. So we have secant of this mess. Well, that would be the same thing as this mess, right? we have a cosine of an angle minus, now it says 90, it's the same thing. Remember the radian value for 90 degrees, due north. Be familiar with that so that you don't look at this and think to yourself, well, I don't have that formula. You actually do. It's right here, right? Y'all see how I'm matching the formulas? It's the angle, and then it's either the plus or the minus, and then it's the pi over 2 or the 90. All right, so this would be, I can replace that whole thing with that. And then I can go back to my knowledge from the very beginning, which if you forget, it is on your formula sheet at the top, because I know your mind is busting at the seams with information. And I can say, oh my word, I can say that that is this, right? Okay, the next slide. So these are called cofunction. Cofunction identities. It's the when you hear cofunction, you should think like it's something is coexisting, right? Multiple pieces. Well, the concept is that there's two things being added or subtracted here. But it's not like 7-1. 7-1 was where it was like, what was it, sine of 5 pi over 12. We had to evaluate that, and we broke it into two fractions that would add or subtract to give 5 pi over 12. This is not the same thing. This is saying, they're telling you from the get-go, hey, you're taking some angle, and you're adding pi over 2 to it, which is called the cofunction identity. It's not the sum and the difference like before where we had to come up with the fractions. We have to take what they gave us and run with it from those formulas. So those are cofunction. Now we're going to look at double angle.
So we're only going to be dealing with cofunctions of pi over 2 to 90 degrees?
Yeah, if you look at your formula sheet, it's exactly what we're dealing with, yes. Yeah. There won't be 3 pi over 2 or 2 pi. It's not going to be there. This slide is deriving the double angle identities. Okay, so instead of me just saying to you, don't write this. Instead of me saying to you that sine of 2x is 2 sine x cosine x, don't write that, I'm about to erase it. Instead of me throwing that at you and then saying, let's practice, I'm going to show you how we get sine of 2x to become 2 sine x cosine x. We're going to derive it, which is what the word derive means. All right. So first we're going to look at sine. We're going to copy the formula for the sine addition from 7-1 right next to it. So sine addition was u plus v. From 7-1 was sine u cosine v plus cosine u sine v. So that's me just copying the formula from 7-1. All right, now I'm going to show you how to apply it. So double angle. Double angle is exactly what it sounds like. You're taking some value and you're doubling it, right? Which means you're multiplying it by 2. Okay, so come right here and say to yourself, okay, so if I have sine, now this is important, because it's the angle that's actually doubling, this needs to be in parentheses right there to show that, hey, it's 2 times the angle, okay? If you write sine 2x, which is fine. There's nothing unethical about it. I write it sometimes. I just don't want you to think this is different than what, like, I want you to still remember that this right here is your actual angle, whatever it represents. And it's saying that we're doubling some X value in order to get that. So just decide how you're going to write it until you wrap your mind around what it is. I would probably put it in parentheses so that you remember it's sine of 2x. All right, watch my arrow here. My arrow is saying, okay, I'm going to take that sine of 2x and I'm going to rewrite it in a manner that fits this formula. How can I get 2x from addition? Don't overthink it, by the way. Adding x plus x, right? Isn't x plus x 2x? So we're just going to rewrite that. She looks scared. So we're going to rewrite 2x as x plus x. Let's see where I'm going with this now.
Thank you so much. I'm trying to.
Is it for bowling? Is it for bowling?
Uh-huh.
What is it?
What is it?
How much is it?
No, she was in it in the campus, but her mom was going to do it over the weekend through credit card or check or something. And so when I'm checking it, because I've got
Sign off. Yeah.
She's in there, but I have not paid. So I
Do you
was.
need it right now so that you're...
Yeah, it's okay. I've got her going. I've got her in there. I just, that money we have to
I know how they,
and it wasn't matching.
Right.
And I said, I don't know.
Right.
So I had to go and do every one of those. She's on my list, but she is in it for the campus, but has no mom.
Okay.
So her mom
Okay.
do it for the campus. I'm so sorry.
You're fine. Amy, I love you. She says it that way every time, and it's so funny. All the time. Bonnie. We rewrote 2x as x plus x. Now we're going to go in here and apply this formula, okay? So where there was u and v, we have it easy. We just have x and x, right? So apply that formula right here. This will come out beside it. So it'd be sine x, cosine x, plus cosine x, sine x. Because every single one of those trig functions has the same of part, right? The of matches right here. Let me show you. Of. They all match. So if you look at it, you have sine, cosine, both of the same thing. Then you have cosine, sine, both of the same thing. So are these like terms? Yes. It's, even though their order is switched, it does not matter. It's just multiplication in between them. So if you just shuffle those to match the same order here, it would not matter. So I have one entity and another entity. So this is 2 sine x cosine x. The 2 is in the very, very, very front. It's like double, and then it's just plain sine x cosine x. Well, it's saying like you would double the whole thing, but we don't get into that. This is just a formula. It's just understanding the formula. So the formula here is that the sine of 2x is 2 sine x cosine x. That's the formula. Alright, now we can very quickly do cosine in the exact same manner. Copy the formula from 7-1 for the cosine of adding two angles together. So we're copying the formula from 7-1. Alright, so that's the 7-1 formula. Okay, so if we have the cosine of the double angle, it would look like this. It would say cosine of 2x. Now I want to rewrite 2x as x plus x. Now I'm going to apply the formula. Instead of u and v, I just have x. So copying the exact same formula. But everywhere there's a u, I'm putting an x. Everywhere there's a v, I'm putting an x. Now I need to clean it up. What's cosine times cosine? Cosine squared. And then sine times sine is sine squared. That is the formula for the double angle of cosine. Now, it looks really familiar. Don't throw in there, oh, it's -1. No, because that's a minus. Remember, it has to be positive for that to be +1. So that's it. That's all you can do. I don't know exactly what you can start on the homework, given how you didn't get very far. Maybe open it up and look at the first problem and see, and if not, pick up on this tomorrow.